Hello, everyone. Welcome to Filling Gaps. Today, we're going to be immersed in the formative cycle. But first, let me introduce myself and tell you a little bit about my why. My name is Jacqueline Wedner, and I have been teaching for 29 years. For most of my career, I was a classroom teacher where I taught third and fifth grades for about 20 years. In the last 10 years, I became and evolved a math coach, and then I was a math specialist, AIS provider. I now work with K-5 teachers in Farmingdale, Long Island. I believe that all students can succeed. I always want my students to leave my room with an I can do it attitude. And my why filling gaps? Classroom teachers are focused on a curriculum which goes at such a fast pace for them that they need time in their day to stop and support the students who are not keeping pace with the curriculum that they're going at. So I'm here to support them in that work. During my years as a math coach, I was fortunate to work with an experienced principal who was just as passionate about math as me. We started a math vertical team, and with that team, we created the formative cycle. It is a cycle that's been tested over time with many iterations across all grade levels K through 5. I will walk you through the cycle today. The heart of the formative cycle is knowing the math beyond the curriculum, knowing the progression of what you're teaching, what came before, and what came after. That's how you know what to do if your students are struggling, by knowing what comes after, and then there's an accountability built in on your part to get your students to where they need to be successful in later grades. Knowing the concept is about knowing the big ideas and or living inside a progression. So for example, if our topic was place value today, I would talk about place value being the system where the digits determine the value. I need to trace that back as an educator. Where did our students start to learn place value? Children began learning place value when they studied team numbers somewhere around kindergarten and first grade. And then there's unitizing, where they're learning that a group is also one. So for example, that 5 fingers is also one hand. They start to learn that a group of 10 is also 110. That foundation when learning numbers, that grouping concept, is at the heart of place value. So let me tell you a story about my summer. I went to Charleston, South Carolina this summer, and I was with my 2 high school girlfriends. And we had lunch, and we decided to get dessert after. So we went into a bakery, and I asked the guy behind the counter that I needed a slice of coconut cake and a slice of carrot cake. Because I was with my 2 girlfriends, I said to him that I needed him to cut each piece into thirds. So I asked him to get 3 containers and take each slice and cut it into thirds. He cut the carrot cake and then told me that he couldn't cut the coconut cake in thirds because it was smaller. And I took a deep breath because I couldn't believe what I had just heard. And it was obvious to me that he was lacking some understanding of fractions. And that's what prompted me to do this presentation in the first place. So let's talk about fractions today. What is one big idea about fractions? Take a minute to think. So let's look at the big ideas. I hope that yours are similar to mine. So one of the big ideas that our students need to know is what a fraction is, that a fraction names an equal size part of a whole. Here's another big idea. They need to know the meaning of the unit fraction, that the unit fraction names the smallest equal size part of the whole. And whatever whole they're looking at, they need to be able to name the unit fraction for it. Also need to know the meaning of the reference whole. So I gave you two examples up on the screen. I usually do this activity with pattern blocks. And as you can see, the trapezoid is worth 1/2 when the whole is the hexagon, but the trapezoid can also have a value of 1/4 when the whole is 2 hexagons. So knowing that your whole depends on the unit fraction is an important concept for our students to grasp. It's also important that they know the meaning of the numerator and the denominator, that the numerator names the part of the whole that you are focused or counting on, and the denominator names how many equal parts the whole is partitioned into. Another concept at the heart of fractions is magnitude. Our students need to learn that the larger the denominator, the smaller the piece or the part. So when comparing 1/3 versus 1/6, because our kiddos in the past learned that 6 is greater than 3, a big misconception that they have is that 1/6 is greater than 1/3. So learning that the smaller the piece, the larger the denominator. They also need to grasp the meaning of the equivalent fraction. If equivalent fractions have different numerators and denominators that name the same part of the reference whole, but it has the same value. So here are the big ideas that lead students to greater understanding of fractions. Do you have the same ones that I do? I certainly hope so. So having a deep understanding of the big ideas in 3rd grade will lead to more success in 4th and 5th grades across fractions and beyond. So now let's get back to the formative cycle. The first step in the formative cycle is to select a high-quality task. This is a task where thinking is involved. It is not a yes or a no answer. There is a rubric attached. So if you look on the page, there's high-quality task is underlined. That's a link that you can click on, and there's a high-quality task rubric that you can look at your leisure. But let's just understand that now. Just real quick, I'm giving you a Cliff Note version of what a high-quality task is, that it's a deeper thinking task. So the task that I have chosen as a formative assessment tool will show whether students understand what a fraction is and understands equivalent fractions. So here's the task. There is a picture at the top of the page that says, and the directions say, name 2 different fractions that describes the green part of the shape above. Explain each one. On the back, there's the same picture, and it says name 2 different fractions that describes the yellow part of the shape above. Explain each one. Now it's your turn, and that's really important to do as an educator because we need to get into the minds of our students and how they're thinking. So pause the video and take about a minute to solve the task. The next step is to anticipate students' thinking. So as the teacher, you are solving the problem to get inside the heads of your kiddos. So the teacher solves a problem so that they can look for what are the possible misconceptions that your students might have. After solving, can you anticipate some misconceptions? I think a student might name the fraction incorrectly, or name the fraction correctly, but they're unable to give an equivalent fraction. I think some kids might be unable to explain the why. And those are just a few. Of course, I can't anticipate every misconception that our students will have. Kiddos surprise us with the way they think. The next step is to gather the student papers and interpret their work. I sort the papers into two groups, got it and don't got it. Depending on what I see, sometimes there's an almost got it group, or you can call the groups high, middle, and low. So let's interpret one together. So I selected this paper, and this is how one student solved the task. I'm going to let you read it on your own and then decide if this is a got it student, a don't got it student, or an almost got it student. Okay, so what did you think? Is this a student that got it, almost got it, or didn't get it? I sorted this student into an almost got it group. They have some understanding, so they said that it's 3/6. They were able to name the green part as 3/6, that there are 6 equal parts and 3 of the parts are shaded, but then they could not name the equivalent fraction. They said 6/12, okay, not understanding equivalence. And likewise for the backside of the paper. They were able to name the yellow part, but not name the equivalent. As an educator, I want you to take this as a suggestion. When I did this as a classroom teacher, my administrator did not allow us to sort our own papers because she felt that there was bias involved in that, because sometimes when you know the students, you tend to grade them a little bit higher than they are. So just as a consideration, if you are doing this work and sorting papers, hand your papers to a trusted colleague and say, sort these for me. So that's just one suggestion. So now that we've done one together, if you click on the picture on this page, it's going to bring you to a Google slide presentation, which has the papers for you to sort. And you're going to move the icons at the bottom of the page and make it got it, don't got it, or got it. So pause and sort the papers. Now that you've completed the sort, let's see if your sort matches mine. So in the got it group, we have papers D, Q, H, R, N, and T. In the almost got it group, we have the A, L, E, O, G, K, and J. And in the don't got it group, we have papers B, M, C, P, F, S, and I. So how did your sort go? Did our papers match? Now that I've sorted the papers, it's time to start pulling some small groups. What holes or misconceptions did I notice? Do all the don't got it's belong in one group, or are there discrete interventions that need to take place? Also, what intervention do the students who almost got it need? Try to keep your groups between 3 and 4 students. So back to the formative cycle. After sorting the student work, it's time to decide on next steps. What are you going to do when you pull small groups for remediation? So in the differentiation box, I have listed a bunch of activities that you can do. All of those activities are going to be in a file for you at the end of this presentation that you can download and help you support your small groups. I'm going to explain a few of them. I find that there's a language component when students are struggling with any concept, not just our English language learners. When speaking the language of fractions, these are the most important words for our students to iterate. students and teachers, by the way. The definitions of these words can be found in the Granite School link that are included in my resource guide on the next slide. During small group work and whole group also, it is important to hold these students accountable for the language. During a whole class lesson, these students can get away and hide, but in the small group, they can't, right? There's just 3 or 4 of them and they're forced to speak. So build in that accountability. So here's the link that I spoke about from Granite Schools. For the students who didn't get it, I will work with them at my small group table. I'm going to begin with a review of vocabulary words. I like to use the Granite Schools vocabulary cards because the last card in the set has a word, a picture, and the definition. The visual supports students who have difficulty with language. Let's look at the kids who almost got it. The teacher looks at each child's paper and lists the misconceptions. If these students' misconceptions are not grouped, I will need to pull them individually. Let's look at that group to see where the misconceptions were. So we're going to look at the kids who didn't get it and list the misconceptions. And in my classroom, I'm just sitting down with a paper on a clipboard and I'm writing student G and I'm listing next to it what that misconception is for that student. And that's how I'm grouping them. So I just want to hone in on a point here that yes, most of the work that I'm doing in my class at this point with the small groups is to support those students who didn't get it. But there's also work that needs to be done with the students who almost got it. And also the students who got it because they weren't perfect papers. I didn't feel that the students' papers who got it really used fraction vocabulary the way that I would want them to. So for the kids who got it, I'm going to have them write their explanations over using specific fraction vocabulary. So I might pull them in a small group and just quickly reiterate what those words are that hone in on our key understanding of fractions and say to them that I want them using at least 3 to 4 of those words in their explanations and then sending them off to do that. But their work isn't done. They still have improvements that they can make. So how are we going to support our students with misconceptions? I'm going to walk you through the folder of resources that I have that you are going to get the QR code at the end of this presentation. So here we go. So here are the activities for the kids who didn't get it. When you click on this link, you're getting these activities. So I'm going to go through each one. This is a unit fraction routine where students are using Cuisenaire rods to name the unit fraction. So they're writing what the unit fraction is. And of course, you have them in a small group. So you're asking them, how do you know what the unit fraction is, right? So you're asking them, how many equal parts is this whole partitioned into? So you're having them take this color and then lining up the white cubes to match it. And that's how they're seeing what the unit fraction is. And then they're doing the unit fraction number bond. And they're doing it for each color that is represented here. So this is a great activity for reinforcing the unit fraction. The last page, I have students choose their own unit fraction, one of the ones that was not pictured here, for them to do the unit fraction and the unit fraction number bond. Here's another activity. Again, this will reinforce unit fractions, but it'll also reinforce equivalent fractions. So I call this activity Name the Fraction Another Way. So again, here is a whole partitioned into 6 equal parts. You can say to them, your students, what is the unit fraction? The unit fraction is 1/6 because my whole is partitioned into 6 equal parts. And when I'm counting them, 1 is the smallest piece. So there's 1/6, and I would have the students count the whole. 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. What do we call the whole? The whole is 6/6. All right, let's go back and name the green part of this fraction. The green part is named 1/6, 2/6, 3/6 because 3 of the 6 parts are shaded green. And then you're going to question them through, could we name that 3/6 another way? And again, that would be 1/2 of the whole is colored in, is shaded in. And then you can say to them, what would we name the white part of the fraction? That's also 3/6. So does that mean that 3/6 plus 3/6 equals our whole? Obviously, yes. And what happens when a fraction is equivalent to one whole? What's the relationship between the numerator and the denominator? These are all the generalizations that we want to question our students through. The next slide is purposeful also. There are 4/8 shaded, and you're questioning them through their understanding of the unit fraction, the half, and the whole. And then there is 5/10. Again, purposefully chosen for students to make the generalization. And you're going to ask this of them. What do you notice when a fraction is equivalent to 1/2? Hopefully they'll see it, but if not, you can question them and say, is the numerator always half of the denominator? And give them more examples for them to reach that generalization on their own. And then there are more slides included. Let me show you the next activity. This is called Fractions with Pattern Blocks. Let me put it in slideshow mode. So remember what I said in the beginning about the reference whole? So I use pattern blocks because this activity reinforces that reference whole concept, right? That our whole changes depending on the size of the unit fraction. So here we go. These are slides. So the whole is the hexagon. They have to find the shape that is 1/2 of that whole. And then the answer is revealed to them. So question them a little bit more. How many of those 1/2s would it take to fill the whole? Hopefully they see that it's 2 1/2s make the whole. And you're going to go through what is 1/3 of now the hexagon. Okay, and the whole changes and the unit fraction changes. And that's the realization we want them to come to. One of the things I would do here also, let me just put it back in slideshow. I would question them through because how is it that our whole here and then the trapezoid is 1/2 and then this is 1/3? Just to question them through, the whole hasn't changed. It's the piece that has changed. That's why the name is different. So that is fractions with pattern blocks. Now I'm going to show you fraction task card. So this is similar, same thing. But now I'm giving them the shape and they have to come up with the name. So here they have the whole and they have to come up with the name of each shape. So these are task cards that you can do with your students and have the conversation around each one. It's not just them doing the activity, it's the conversation that's really important. Then this is the high quality task. I put that in the folder for you so that you can copy it. Just know that I included it in color, but I also put it in black and white because depending on what access you have in your school, there are days that my color printer's down and I have to copy things in black and white. So you have the option, and here I've labeled the parts for you. This is the rubric that I mentioned in the beginning about high quality task. So here are the criteria for high quality tasks. Okay. The ones that are bolded, those are the musts. So a high quality task allows multiple entry points. All students can begin the task and the task can be extended. It also connects to previous knowledge. It also connects previous knowledge to new learning. It closely aligns to the unit's big ideas, and it allows for multiple strategies. Those are the musts, and then these are mights that are below that. And you can peruse those at your leisure. Also included in the folder are the fraction papers, the students' work, for you to sort through. Those are all included. So these are the ones that you sorted through that if you want to print them and have conversations amongst your grade level in your building, you can do that. Or also if you're a coach, you can print these for a professional development session. And those are the tasks that I have included to help you support your students. If you have any questions about the tasks, feel free to email me. Now, here's an opportunity for you to watch a video. I taped it using BrainingCamp, and BrainingCamp to me is the pictorial representation that supports our students in the CPA approach. But what's important to me here is that with your students, you're also using the tools. So for that concrete piece, if I'm using the Cuisenaire rods, I hope your students will have the Cuisenaire rods in front of them, modeling what is happening on BrainingCamp. I really think it's important that we don't forget that C part in the CPA approach. So as you're watching the video, think about what your students will have in front of them as you're modeling with the tools on BrainingCamp. In the video, you're going to see me ask questions to guide students' thinking. Today, we're going to talk about fractions and naming them. So I'm going to start off with a light green Cuisenaire rod. That's my hole. And now I'm taking a white Cuisenaire rod. What is the value of that white rod? What would I name it? Let's see how many of them it takes to compose the hole. It takes 3 whites to be the same length as the light green. Do you have any thoughts about what the white Cuisenaire rod would be named? I hope you thought 1/3, because there are 3 equal-sized pieces making up the same length as the light green Cuisenaire rod. So I would name each of these 1/3. So let's count them. 1/3, 2/3, 3/3. So 3/3 makes my hole. Now let's talk about the purple rod. Here's my hole. And now I have a red Cuisenaire rod. What would I name the red Cuisenaire rod? Let's see how many it takes to compose the hole. It takes 2 reds to be the same length as the as the purple. What would I name the red Cuisenaire rod? Any thoughts? I hope you thought 1/2, because they're 2 equal parts making up the same length, the whole, the purple rod. So this is 1/2, and this is also 1/2, but when I count it, it's 1/2, 2 halves. Now let's do another one. Now I'm going to take the dark green rod. That's my hole. And now I'm going to take a red rod. What can I name that red rod? Let's see how many of them it takes to compose the hole. It takes 3 red rods to compose the dark green and be the same length. So what would I name this red Cuisenaire rod? How many equal parts make up the same length as the dark green? There's 3 of them. So each of these pieces would be 1/3. So here's 1/3, 2/3, 3/3. So I have a question. How is it that the white piece over here was also 1/3?
How is the white piece and the red Cuisenaire rod, how do they have the same name? And the answer to that is it's because the reference hole. This hole is a different length. It's shorter than the dark green rod. So the name of my fraction depends upon the size of the hole. Likewise, I had the red over here named 1/2, and here it's named 1/3. How is that possible? Again, because of the reference hole. So now let's do one more piece. Here's the brown piece. I want to know what I'm going to name the red Cuisenaire rod. Let's see how many of them it takes to compose the whole, which is the brown. It takes 4 red pieces to be the same length as the brown. What would I call the red? What fractional name would I give it? There are 4 equal parts, and this is one of the parts. So my unit fraction is 1/4. And there are 4 1/4s that make up the whole. 1/4, 2/4, 3/4, 4/4. Now let's build it with purple. Now there are 2 pieces of purple that make the same length as the brown. What would I name the purple? This would be one out of the 2 parts, one of the 2 equal parts. So this is 1/2. And here is the other half. So my whole is composed of 2 halves. Do you notice that one of the halves is the same size as 2 of the 1/4 pieces? In math, we call that equivalent. So 1/2 is the same as 2 1/4 or 2/4. I hope this helped some of you with the language. The other question that I would consistently ask as I'm going through this with students is, what is the unit fraction? Here, the unit fraction is 1/3. Remember, the unit fraction is the smallest equal size piece. So here it's 1/3, here it's 1/2, here it's 1/3 again, this is 1/4, and this is 1/2. So I hope this video will help you to help your students.
So you just took a couple of minutes out. The video was about 5 minutes long. And I hope what you paid attention to was my questioning through for students. If you noticed, I consistently ask them, what is the unit fraction and what is the reference hole? And they have to explain each time why they're naming the unit fraction, what they're naming it, and why they're naming the reference hole, what they're naming it. Those are key big ideas that our students are understanding about fractions. So it's important that we keep using that language and questioning them through their understanding. As I begin to fill gaps, I want to track my students' progress. So here's a suggestion. And again, this is a link that if you click on that, it leads you to a spreadsheet that you can make it for any big idea that you're doing. So if you look at the sheet, I'm simply listing along the side the students, and then I have at the top the big ideas of fractions, because that's what I'm in the process of trying to remediate. So as I'm going through the small group work, I'm literally next to each child's name, putting a check or a minus when I see that they're grasping. And again, that's by observation. And I'm only able to do that work by knowing the content and hearing the language that the students are using when I ask them questions. One of the questions that I get all the time is, where do I find the time to work with these kids? This is our biggest struggle as educators. Let me just say, I've done it. I've been a classroom teacher for 20 years, and I know finding the time is hard, but there is time in your daily schedule to do this work. I take about 5 to 10 minutes when I'm pulling these small groups. I am not just pulling them during math workshop time. I'll pull them as they're independently reading. I will pull them as they're coming in the morning and unpacking. But there is time in your schedule to find the time to do this work because our kids really deserve and need us to spend time remediating their misconceptions. So here are a few suggestions. I'm going to go through each one. When you are pulling your small group, it is important to guide them through the CPA approach. You can read the slide at your leisure, but just a cliff note of this is the concrete version. Being concrete with your students involves using manipulatives. They need to be in this stage to make sense of the math. And then we're moving them through the pictorial representations and then the abstract representation for them to gain understanding. Vary your tool. It is important that our students see that a fraction is not always a pizza. So I use Cuisinart rods and I use pattern blocks. Those are the first tools that I use in remediation because I want them to see that the whole, that reference whole, changes depending on the unit fraction. What you write matters. When I first start talking to our students about fractions, I will name the fraction 3/1/4. Okay, that takes into consideration the unit fraction. That when you're saying 1/1/4, 2/1/4, 3/1/4, the unit fraction is 1/4. Then I transition to writing 3/4, and that's like 3 apples. So again, that unit fraction knowledge of 3/1/4. And then the last thing that I do is give them the fraction representation after they've had the understanding that I am counting unit fractions. Another suggestion is to ask the right question that will lead to greater understanding. Those questions come from knowing the math. And when you watch the video that was a few slides before this, where I go through the braining camp using that those manipulatives in braining camp, I'm connecting to vocabulary. I'm asking the students, how do you know? And most importantly, I'm asking them why. These are really pivotal for our students to gain understanding. So now that I've led these students through the formative cycle and I've done these remediation activities, it's time to assess again. Has the small group remediation worked? Now, some teachers like to give the same question, and you can do that as long as you didn't use it in small group work. I'm a firm believer that talking louder does not support our students. Just because you go over that question with the students, that's not them gaining any understanding. So instead, use a different high quality task. So here's another task that I came up with to assess the students with. It says list at least 2 fractions in each column. So in the first column, it says list 2 fractions that are equivalent to 1 whole. Next column, fractions equivalent to 1/2. And the last column, 2 fractions that are equivalent. And then I'm asking them to explain why they placed 1 fraction where they did. If you want to increase your knowledge of fractions, I can recommend this book as one that has increased mine over time. It's called Extending Children's Mathematics Fractions and Decimals, written by Susan B. Empson and Linda Levi. So here is the barcode that will give you all the resources that are in this presentation. So let's work together to support your students. I hope that I've helped you today with the formative cycle.